Okay, welcome. I guess we're going to start now. Maybe some people are dropping in later. Guess that's okay. Let me welcome you to our presentation. The next minutes are going to be about the API management in a distributed cloud environment based on OpenShift. The speakers are Christoph Eberle from Red Hat, Christian from IPT, a partner from Red Hat, and me, Thomas, from the SBB. We have been working together to build up what we are going to show you in the next minutes. Short overview, I'll skip this. The story of APIs in our company is based on a fundamental belief that this sentence is true. It's called classic industries must embed their physical assets in an ecosystem of software services in order to create new customer journeys. And we believe actually quite similar to what Red Hat believes, that openness is also for a company like us, a very old company. We are over 100 years old, the Swiss Federal Railways, building trains, a very classic company, but still in order to move into the future, in order to innovate and bring up new products, we have to open up ourselves, and doing that, the most important part is having APIs, having managed APIs, and that's why we are going down that road. We have two perspectives on API management. I will show you first the more business-oriented perspective, and later on we go into technical depth. So the outside goal of APIs in our company is to provide some interfaces, some APIs to the outside world where we can interact and where we can join the value proposition chains, and where we can join the other ventures with our APIs. We want to be accessible from the outside in order to profit from innovations that are not from inside out, that come from the outside world. Here are some examples of APIs, and we guess we will have a lot more APIs, and we want to be a platform, not just a transport company. We want to be a platform where you can interact and where you can build up innovations on top of that platform in order to consume our hardware. The hardware is the train, the rails, our schedule, and these things are the assets coming from our history, and we want to make these accessible to the outside world. So we have, for example, we have a booking API. This is the most important one. That's where you can buy a ticket, and at the moment you can only buy tickets over our website. This is our front, this is our face, and we'll have other faces like APIs as well. The more technical part, why we are looking into APIs, is based on OpenShift, based on the movement and direction of microservices, based on that applications that have been big are cut into smaller pieces, and every small piece exposes its own API or service. So you'll have kind of a service mesh, and the service mesh needs to be controlled somehow. And that's the other reason why we're looking into API management. So there is a business-oriented need, and there is also a technical need why we are looking into this one. And the second part is really important for what we are showing you later, because the second part implies that the API management infrastructure scales to very large requests per second. These are some numbers of our setup from OpenShift, and the API management infrastructure is based as well on OpenShift and is supposed to be used by more or less all of these applications to expose an API. in our vision, we think it will be necessary for every application to expose a managed API, because we want to reach self-service not only on infrastructure as service level or platform as a service level. We also want to have self-service of the level of accessing data and functionality that we build in our applications. And we are doing this with the API management. Our setup of OpenShift is now, we have two clusters, a private cloud that's called the SPB OpenShift cluster, and another public cloud on AWS. Maybe there will be following more on Azure or whatever. We are not yet sure where this is heading. And within that mesh, we want to have one setup of API management. We want to have one view of all the APIs that you can consume. And this is quite being a challenge, actually. Yes.
So, what have we implemented? We evaluated Threescale as a product of our choice to run on OpenShift. This is the architecture, very high level. As you can see, we have very distributed API gateways over all clusters, at the moment 2, perhaps more in some times. We have centralized API management component, where all configurations, rate limits, and whatever are configured. The setup is we have shared API gateways for common use case for most APIs which do not need special requirements. But with this architecture, it's also possible to have dedicated gateways for application which requires special security, special authentication, perhaps have great payload so they do not interfere with other gateways. For example, the timetable API, when it's coming, has a huge load, so it's possible to have a separate gateway for the timetable API, which do not interfere, for example, with the booking API. That's very important. What we also have is OAuth as a standard authentication authorization. And yes, that's our architecture from a very high altitude. Developer portal, the engagement component of Threescale, very high customized. We built some, let's say, API marketplace. As you can see on the left side, it's here. All APIs can be searched via tags, via keywords. And if you dig in, you become the documentation of the API. This is what people see from the outside and can use. So now let's get into details. So as you know, no product is perfect, even Threescale.
What?
So the first thing we had to do is we had to separate the gateway component from the management and the developer portal component. That's because we wanted to distribute the gateway over multiple clusters. For this, we made our own OpenShift template just for the gateway. Second, we needed some customizations. Since the strategic client technology for the SPB is Angular, we had some pretty great trouble with CORS. We had to choose between, do we handle CORS requests in the gateway and deliver back a fixed response, or do we let pass CORS requests, options requests, unauthenticated to the backend and hope the backend is implementing these requests right. We decided to do this in the gateway, so no unauthenticated requests can go through the gateway. For this, we added a customization. Second thing is two-way SSL, mutual authentication for the backend. It has to be possible to make sure that a backend is only reachable from a gateway. For this, we needed two-way SSL, also a customization. And the last one, token cache. Threescale gateway relies heavily on the management component. It's a synchronized communication, and therefore, if the management component, for some reason, it could happen, is down, no gateway will work anymore. For this, we implemented also a customization with a token cache. So if the management component is down, we buy us some time to bring it back, and the gateways are still working. Developer portal customizations. We choose to make our own backend for the whole developer portal. As you saw before, the marketplace view is based on APIs JSON. APIs.io is the page of this, the technology. And we heavily customized the CMS. It goes even further, but this comes later. In the picture you see, we have here, very bad, the course customization, the two-way SSL customization, the token cache customization, and here our developer portal backend customization. So, not very much, but quite a few. Some of them will find their way into the final product, and sometimes some of them are really customer specific. A byproduct. As we choose Threescale for the API management, we knew we needed also an OAuth server. Since SBB wanted to integrate as many IdPs, identity providers, as possible, internal and external, it was sure we needed a lightweight identity broker. The decision was to choose Red Hat SSO, Keycloak, and use it as only as an identity broker. There are no identities inside Red Hat SSO in our architecture, and use it as a central OAuth server, token server for the whole API infrastructure. As you can see, at the moment we integrate two internal IdPs, an LDAP and the AD for internal users, and a lot of external IdPs, Microsoft, GitHub, Google. SwissPass is, how do we call that? A Switzerland unique identity. It's a public identity, is also integrated. And this is just a byproduct, but it works now and has become the strategic SSO solution for SBB. So, how do you get your developers to work with the API management? Normally, you call them, hey, I need an API, please configure it for us. That's not the way we wanted to do it, so we invested a lot of time into automation. The result is this picture. We have developers down here writing a configuration file. It's in our specific DSL, where all more or less relevant information like what are URL mappings, what are limit requests, all that kind of stuff are configured in this file. The next step is we make this into an artifact and we can start a process. We built a Spring Boot microservice which reads out the configuration file from the repository and starts automate the whole setup. First, it automates Threescale and configures the whole API. Then it starts configuring Red Hat SSO, Keycloak, the client secrets. It automates DNS entries in Amazon DNS, Route 53. What's not implemented yet, but it's coming, is a mock-up automation. So the developers can use a mock-up service in the developer portal. So no request for try it out comes into the SBB internal network. And last but not least, developer portal backend is also automated from this configuration file. With this setup, it's possible for developers, API developers, to publish their APIs in just one click to the internet, to the intranet. It has automated DNS, automated certificates. A mock is also automated, so ready to use. No manual interaction. How do we monitor the whole thing? Everything is logged into Sematext. It's kind of an Elasticsearch as a service, a SaaS solution. Monitoring data is going to New Relic from almost every component. And to have a unified dashboard, we use Grafana. So operation for the whole API management platform can use Grafana with a whole complete view and don't have to log in every other tool, just use one. It makes it really easy for monitoring. For that, last slide, for technical details, we needed some helpers. The automation, microservice, Spring Boot, small application, the whole API in one request. We needed a synchronization microservice which synchronizes API management component with the Red Hat SSO component because of the clients and client secrets for the OAuth authentication. And the developer portal, we implemented also Spring Boot microservice to provide the APIs JSON for the whole API marketplace view in the developer portal. Yes, that's it. That's
very interesting. Good, thank you very much. I will have just a few words on a very important topic, which is collaboration between the companies. We were teaming up for almost 1 year now. Really started working on Threescale just when it came out on top of OpenShift, so on-premise. Very early adopters. This has good things and as well produces sometimes some difficult situations, that's clear. But we were really teaming up very intensively over the last year. Overall project ownership, of course, with SBB, with Swiss Railways, they did all the project management, architecture, implementation, and in the end they will operate it as well, the whole solution themselves. So as well making the solution operation ready, creating all the operational handbooks and everything, and transitioning it to operations. This was all in the scope of what Swiss Railways itself delivered. Then we had IPT as an implementation partner who was intensively involved in all architecture and design decisions, and as well did a great job on implementing the solution in the end with all the glue which was needed in between to make everything work. As well, from Red Hat side, we had an intensive involvement across basically the full stack of people what we have in Red Hat. We have the account team, certainly which I belong to, trying to put all the pieces together. We have technical account management, which was supporting us very intensively. The regular support, which was doing or is still doing a great job. Engineering and product management from Threescale itself. So we have very, very regular exchanges with the product management to give feedback, what is working well, what is not working well, what other things are needed, and align this to the roadmap. We had direct and still have direct links into the Threescale engineering team to align the roadmap with them as well and give feedback, as well provide input, because in the turn of the project, we have developed assets which are probably going back into the product itself as well, and to align on this. And as well, consulting services from Red Hat was involved to support on certain specific topics where it's really product-related and product-near things. So you see, it is an intense project, a lot of people, a lot of stakeholders involved, but that's needed in order to make such a project a success in the end. If you look at Threescale as it comes out of the box, that's pretty much it. So you have an API gateway, Nginx-based, which is sitting between the API consumer and producer. Then you have the API manager, so the backend, where all the administration of the APIs is done, where you have all the billing features, metrics, and so on and so on. And you have the developer portal, where actually the developer goes into, sees all the APIs, he subscribes to APIs. That's what Threescale is out of the box, all running on OpenShift as it comes. The first thing we did together, because we sat together, looked at the product, and said, okay, there is certain things which are not going to work for us or for the specific setup we have at Swiss Railways. And one thing we talked already briefly about it was caching policies. So we implemented a set of specific caching policies in order to fully decouple the gateway which is executing the policies from the backend. So out of the box, there is a dependency between the gateway itself and the backend of it, because somewhere you have to create a consistency if you're running multiple gateways, and that's basically done in the backend, and therefore there is a dependency to it. We sat together, looked at this, and defined a set of optimizations or recommendations how we could decouple the two components. And this is basically what we are implementing, or what is implemented in terms of caching policies. So you have very flexible way to define what things are cached on the gateway itself and how it should behave if it loses the connectivity to the backend. This is very important in order to get into a state where you can really horizontally scale the gateways almost to infinity. And this was really one of the key things we had to do very early in the project, because we are talking about, I don't know if this number is still holding true, but we were talking about around 100,000 requests a second, which should be processed by the API management solution in the end, and therefore you really need a very well scaling solution. The second thing then was that we said, okay, we have these caching policies that fits for a certain, to a certain extent, but we probably need something more. So we need to really have a fully decoupled gateway which can run independently of anything else. And first we started and try to document these things. How should it look like? Do a proper design and specification. But at some point we saw it's difficult to describe these kind of things, and SBB started to implement their own gateway. It's not Nginx-based because they don't have too much knowledge in programming Lua. So what they did is they just implemented a Java-based gateway, which is completely independent and very specific to the use case they have at SBB. So you probably lose consistency, but you have a fully decoupled and infinite scaling gateway. What we are going to do now, we have taken the code, what they have produced. You see always as well the GitHub links. That's all open sourced and available. We from Red Hat we have been looking at this implementation, and we will take basically the implementation they have done and put it into our product as well as an additional policy, caching policy, which really will fit the use case from SBB as well. Sometimes a bit of code is saying more than 1,000 words, and this is what happened here. So they wrote the code, this is what it should look like, and we are going to take this over into the product. Should come in one of the upcoming releases into Threescale as well. Another thing we have been looking at, Threescale relies heavily on Redis for caching purposes, and certainly you need a high available ready solution. That's not a thing which is just there like this on top of OpenShift. We have been looking at different things, different scenarios. We have, with Red Hat Consulting Services, implemented a high available ready setup on top of OpenShift. And the second option, what we are just exploring now, and this is probably the way forward, is that we move the whole API manager part from on-premise into public cloud on AWS, utilizing the managed AWS services for Redis as well as MySQL. Because this simplifies a lot of things. You don't have to take care about the HA setup of Redis and MySQL, simplifies operations and so on. So this is probably the strategic direction forward. Coupled to the decoupling part I was talking about, because you have to have a fully decoupled gateway in order to be able to run the backend part on AWS, but gateways itself on-premise as well, in order, otherwise you will have issues with latency. Therefore, it all comes a bit together there. Once we had the decoupling, we could move the backend into AWS. Another thing we have been looking at is MySQL is needed by Threescale as well to store configuration data and so on. And SBB internally was operating Oracle databases, of course, and MS SQL, and they did not want to add another database because you probably know this comes along then with a lot of imposes a lot of additional things. You have to operate another database technology, you have to have the backup restore procedures, and so on and so on. And that's a lot of effort which would have been imposed there. And therefore, together with Red Hat product management and engineering, we were working on supporting Oracle database as a backend for Threescale instead of MySQL. And that's as well a thing which is just about to be shipped. And last but not least, there were some very specific needs in terms of how SBB wanted to present the APIs to their developers. So really having a marketplace nicely integrated with Red Hat SSO, and therefore we decided to, or they decided to, we didn't force them, they decided to build up an own developer portal really, which is very specific to their needs. As well, this is open source. We are still looking for other customers interested in participating in this. So if you're interested, have a glimpse there, and you're certainly welcome to join and contribute there as well. Yeah. Now, Thomas would wrap up the session, the key takeaways, and as well a little bit on the roadmap, where the whole project is going, and then we probably still have time for some questions.
Thank you, Chris. Yes, you probably have noticed that we actually did more customizations that we wanted to do at the beginning, but still it was, in our perspective, it was necessary, and I think we had a quite good collaboration together with Red Hat. So I think we will continue this journey like this. The key takeaway is mainly when you want to scale high, it means you have to accept some kind of trade-offs. It's typically the cap theorem that we were fighting with. So we decided to make some trade-offs on the C, on the consistency, in order to be able to scale up. And at that moment, when we did the decision to make some trade-offs on the C, everything was quite more easy to go on, and we realized that for us it's okay to skip the C, meaning when you have a managed API that's configured to allow 100 requests per client per second, and this client may access 120 times and not 100 times, this is okay for us if it's in a certain limit. So we accept the consistency part to be a bit of more or less accurate, and we try now to compensate this consistency with several additional implementations and engineering, and we are really sure that we will find a trade-off that fits the high scalability and a good enough consistency in both. What we also recognized, for the gateway, it's very, very important that I remarked it in red there. It's very important that every call that's going to a backend, Threescale backend system must be done asynchronously when you want to scale close to linear. It's not possible in a synchronous way, and that's quite a huge change in the whole architecture, how Threescale works. That was mainly the part of our discussions with Threescale. We had a lot of discussions and architectural discussions, and yeah. But I think we found now a very, very well trade-off. The roadmap looks like this. With our implementation, we have done it in Java. Actually, Java is not the right technology to write a gateway. But still, with the Java gateway, we're able to scale up to 50,000 or 100,000 requests per second now with the prototype already. And in the future, this implementation will go into the product in Threescale. That's the plan now. So we will have a gateway with these customizations or with this behavior, with this decoupling, and we will still also have the possibility to use the Java implementation as a library directly in the application, so we don't have a gateway at all. This again comes with some trade-offs. So if you block the number of requests directly on your application, you need to know, developing the application, that you will be fired by requests, so you need to know this. But there are some use cases where this fits as well with us. So we'll have both of them. We will also open source the code. And because we hope when we open source it and some other companies like it, we hope that they will bring their IDs with it, and they help us develop even better software. Yes, we will onboard more APIs, and most importantly, the most important APIs in our company. This is still a long way to go, because the APIs don't need to be just a REST endpoint. It needs to be a good REST endpoint in order to fit the requirements that we have that I exposed at the beginning. And we're also looking at streaming APIs. At the moment, everything is based on HTTP protocol, but we believe that the same kind of managed APIs for request response types also fit for streaming types. We don't know yet how to do this, but we have it on the roadmap, and we believe it will be ready in the future as well. Twitter already has done it, but not in a reliable way.